So, as you may have seen from the title and signing up, today's piece is on self-evaluation bias. And the question that we want to be asking is, should I use the same LLM when I'm building my agent and running it? And then should I also be using that LLM when I go ahead and evaluate? So we have this whole experiment that we ran, and I'm just going to get into it. Yeah, we can go to the next slide. So the first question to be asking here is just what do we mean by self-evaluation? When we're building agents that use LLMs, which is most agents when we think about, maybe the LLMs in the router, it's in tools, it's in sub-agents, anything like that. How should we approach LLM as a judge evaluation, which is one of the most common ways to evaluate agents? The question becomes, should we use the same LLM for both the agent and the judge, or should we use a different LLM for the agent and our judge? And what's the best practice here? You can go to the next slide. And one of the concern that we're looking for here is not the question is like, why do we even care if we're using the same one or the different one or a different LLM in our judge? And it's because we want to test to understand if there's actually any bias in self-evaluation. Does an evaluator score their own outputs higher than they score the outputs produced by other models? Meaning, if an OpenAI judge is scoring the outputs of an OpenAI LLM, is it able to recognize its own patterns? And if it does recognize its own patterns, does it in that case say, hey, I'm going to judge myself higher and consider myself to be more correct in this scenario? And bias can also be in the other direction. Kind of, is a model possibly more harsh on itself? And this is the main question we want to explore. We can go to the next slide. Yeah, so just to be absolutely clear about where like the LLM can be in an agent structure, you're probably familiar with this, but you send a task possibly into a router. That router is equipped with an LLM, a prompt, the LLM itself, and then maybe from there the router determines okay, we're going to send this to some tools, access some memory, maybe go to subagents, and there's going to be LLMs possibly in tools in those subagents. So these are just all the different places where the LLM can exist in an agent, one. And then two, in our own agent today, what we did was we had a router. The router was an LLM, was making an LLM call essentially to determine one of three tools to send an output to, send a task to, and those three tools each were also equipped with the same LLM. So the LLM was in multiple places within the agent, but we were absolutely clear to make sure that the LLM was consistent. So it was the same one in every place of the agent. We can go to the next one. And then to also just be explicit about LLM as a judge. I'm sure many of you have seen LLM as a judge or possibly use this in practice as well. But the evaluator in the LLM judge case involves an eval prompt and an eval model. The model is what we're going to be switching out today. The prompt maybe is going to say, hey, check for hallucination, check for correction, check for correct retrieval. And then we inject our data into the prompt in some sort of places for variables. And then the evaluator output is going to give us some label, a score, and an explanation. The labels can be something simple like correct or incorrect, or you can get quite complex here. And because we're using LLMs in our judges, we also get this higher dimensional feedback for explanation. So that's just a little bit on LLM as a judge, but yeah, we're ready to go on. Oh, I think you're on mute, Elizabeth. There you
go. Okay, so before we get into the experiment that we did, I want to talk a little bit about the larger research context here and the research on egocentric bias in LLMs. There are probably now a dozen or so studies that have demonstrated egocentric bias, as well as other biases in large language models, especially when used as a judge. And many of these cognitive biases are similar to biases that humans have. So, for example, LLMs demonstrate a kind of positional bias where they have a preference for an output based on its location in the presented order. But some of these biases are unique to LLMs. for example, verbosity bias, which is the tendency of LLMs to prefer outputs that are longer and more verbose, and also egocentric bias, which is the focus of today's talk. And egocentric bias is the tendency of models to prefer their own outputs. So to prefer outputs that they generated themselves, and to assign higher scores to them compared to sort of outputs of equal quality. And these studies are often structured as a pairwise comparison task, where first you have different models used to generate outputs on a particular task. This could be anything from summarization to translation, structured problem solving, et cetera. And then you use those same models as evaluators, as LLM as a judge. And you present these judge models with two outputs. One of the outputs is the output from that same model, and one is from another model. And these outputs are anonymized, and the judge is asked to indicate which of the two they prefer. And then they indicate which ones that they prefer. And this is how we see the egocentric bias. So models tend to prefer over and over again, regardless of the model size or of the model family, they tend to prefer their own outputs. That is, even if they don't know which is which, right? So this then begs the question of like, how do they know which is which, and why are they demonstrating this preference? And that there's now been research into kind of digging into, well, why does this happen? I'll also note that this bias is present because, in addition to the fact that it's misaligned with human judgments. So the models will prefer their own outputs, even if that is not what the human judges prefer when presented with the same options. And this is obviously problematic because we want our LLM judges to basically scale up our human evaluations and replace them. But if they don't share the same preferences, that is a problem and will impact our evaluations. And more recently, we've started to dig into the reasons why this is happening. And interestingly enough, the models actually are pretty good at recognizing themselves. So there's a clear link between the model's ability to recognize its own outputs and its tendency to prefer those outputs. And we believe now that there's a relationship between the perplexity of the outputs and the model's tendency to recognize them. And perplexity is basically a measure of the kind of probability distribution of the input or output tokens that give the model a sense of familiarity. So when the outputs have low perplexity for that particular model, they tend to prefer those outputs, whereas humans don't demonstrate this preference based on perplexity. So that is one of the reasons we believe this is happening. And continued research will go on to this, but in the studies, there seems to be some evidence that larger models are less prone to this egocentric bias. But again, it's observed in all of the models and all of the families, regardless of size, and has more to do with how well they are able to recognize their own outputs, more so than other features of the model. All right, back to you, Sanjana.
Okay, awesome. So now we're ready to kind of just go into the tests and experiments that we were running here. We focused on 4 specific models here, one from OpenAI, Anthropic, Google, and Qwen, an open source model. We found that each of these providers represented a strong option, and we didn't want to, isolate the experiment down to one specific ecosystem. So we have GPT-4.1, Claude 3.7, Gemini 2.5 Flash, and then our Qwen model here. And taken together, this was, again, like some well-rounded choices for um, this experiment. So we constructed an agent and we ran an agent using each one of these models. And we did this on a data on a fixed data set of 50 questions, and the 50 questions were the same across each run of the agent that we did with the models. So then after we ran the agent with each of these models, we then went ahead and did an evaluation with each model. So if that sounds a little confusing, you can think about it this way, like we ran the OpenAI agent. We ran an agent with the OpenAI model, and then we took the outputs of those agents. We took the output of that agent and evaluated it with OpenAI, Anthropic, Google, and Quen, and then we did that for each one here. So that gave us a total of 16 experiments. And also to ground our evaluation, we included human annotation scores that served as our ground truth throughout all of this. Um, so we weren't just anchoring down to one specific evaluation score. We always had the human truth to go back to and say, hey, this is actually our baseline of comparison. And if we go to the next slide, I have a diagram drawn out of this just so it's absolutely clear of what we did here. This might look a little blurry, but bear with me here. So we had a question that went into an agent. The agent was powered by varying LLMs. That's what these four initial branches from the agent are. So we had the OpenAI response, an Anthropic response, a Google response, and a Quen response. And then we're going to follow the path of the OpenAI response here, but the same thing applies to all four branches out of the agent here. We took the OpenAI response and we first assessed it with human feedback, and that was our ground truth, our reference score. And then we did LLM as a judge with each of the four models once again. So we took the OpenAI responses, we evaluated it with OpenAI, Anthropic, Google, and Quen. So now for each of these, we had 5 feedback scores. And then if we go to our next slide, we can actually look at what the evaluation looks like, because this entire time I've been saying we're going to evaluate with LLM as a judge, but what exactly was our evaluation criteria? If you were to run this experiment on your own, you could come up with any sort of evaluation criteria. In this case, we chose orchestration quality. This tested how well the model coordinated tool use to produce a coherent, accurate recommendation to the user back. We had a pretty strict rubric that we have a tiny screenshot of here, but in our write-up, it's more clear there. But basically we were asking the judge to determine whether the right tools were invoked, if the outputs from those tools were integrated meaningfully into the final answer, and if that response directly tied back to the user's query. So it was an orchestration view overall. And we also really specified that even small gaps like skipping a tool or doing redundant steps would knock the score down. And then we also specified some evaluation output here. So the output labels were either going to be good, partial, and bad, and those mapped to scores from 0 to 1. And then again, we were able to get an explanation of why that label was assigned for a certain judge, because we were using LM as a judge in this case. Um, yeah, and now we're ready to finally jump into some of the results here. This graph may be a little confusing, so bear with me and I'm going to walk through this step by step. So the first kind of experiment that we ran here was a hypothesis test, and we were asking, does an evaluator consistently score their own outputs higher than they score outputs produced by other models? So if you need help reading this, essentially each row represents an agent and how it performed, and then each column represents the eval model. So if we take this top row with OpenAI, when we ran the agent using OpenAI, the human judge gave it a score of 71%. And then when we evaluated OpenAI with an OpenAI eval, we got 65. When we evaluated it with Anthropic, 89, and so on. And if we look at this column wise in this case, I tried to keep the colors the same in each column here. The key comparison we're trying to understand is this score of 65, how does that look compared to how OpenAI evaluated the outputs of other models in this case? So that would be the 75 here, the 34.4 here, and the 57.6 here. The key comparison we did in this case was between the evaluator's score for its own model. So that's what's on the diagonal here. It's those self scores and the average between how that evaluation model scored other agents. So that would be the off diagonal values in the column here. If we found that, oh, sorry, we can still jump back one. Sorry. If we found that the average between these three was higher than the self-evaluation score, then that was some indication of bias. Now we can jump over. And that was kind of this calculation that we did here. So we looked at each of these diagonal scores. That's what this self-eval score was here. And then we looked at how the average of other eval scores, and this was kind of our baseline for comparison, and we computed a delta. If we looked at the delta for every single evaluator in this case, we saw a positive deviation. And this signaled to us some initial signs of self-evaluation bias. As part of our experiment, we also did bootstrap the results to estimate some confidence intervals and just show some consistency. We did run multiple trials for all of this, but bootstrapping just helped us um, understand where these values fell overall. The key takeaway from this first hypothesis test is that all evaluators tend to like their own outputs more when judging on their own scales, and that's represented by these positive delta values. We see that the self-eval scores tend to be higher than the averages across the board. However, you might be thinking that the scope of this is quite limited. It doesn't really control for the underlying quality of the models itself. Maybe OpenAI rated Anthropic higher because it felt Anthropic's outputs were stronger. Maybe that's not model bias, or maybe it's a combination of the two. So in the next test we did, we brought in those human scores in that first column that we were looking at, and this helped us actually ground these findings a lot better. So I know this graph is probably even more confusing from the last, so I will also take a second to just explain what's happening here. These are the exact same numbers that we're looking at before, except now we incorporated these delta values, which kind of are we annotated with these delta values here and brought like some different coloring here. But what these delta values are, it's a deviation from the human judge score. So if we look at, let's take the OpenAI case again in this example. So we look at the top row, which is OpenAI. The OpenAI agent got a score of 71 from the human judge, but when OpenAI evaluated OpenAI, it got a score of 65, and this was a delta value of -6 from the human score. So we computed these delta values for all 16 of our experiments, and I also did some coloring here. The lighter colors in the 16 experiments represent a smaller deviation away from the human score versus the darker color represents a greater deviation. So if we look at, for example, the Quen eval model evaluating the OpenAI agent, so that's the top right-hand corner, it's quite a small delta value of -1.4 versus if you look at Google's self-evaluation score, so Google evaluating Google, it's you can barely see it, but it's a 72.5 because it just has this crazy high delta value of 31 points above the actual human score that it got. So from here, we could now ask a sharper question because we've aligned with human scores. The question now becomes, does the evaluator still assign extra credit to its own model, even after accounting for true model strength? And when we have these comparisons for how it's inflated or deflated against a human score, we're kind of putting all of these models and all these agent performances on the same scale so we could actually make a more fair comparison in place. Um, and it kind of just it gives us a clearer view into if any special treatment was actually made. So we can go to the next slide and we can see the results from this. Once again, the diagonal represents our self-eval scores in this case. So this is all in perspective of these delta scores from the human value. So the first column is our self-eval scores. And then once again, we took the average of all the other eval scores. So this is still a column-wise comparison. So how did the OpenAI self-eval score compare to how the OpenAI judge scored all the other models. And the result here was that the OpenAI scores are essentially neutral at a delta of zero point 0, 0.33. So there wasn't much of a there wasn't much bias that we saw in this case. But we also did see that Google strongly inflated its own outputs relative to the human scores, and this was a huge jump compared to anything else we were seeing here at 37.1. And then in contrast, Anthropic and Quen were at -7.4 and -5.7 respectively. And this was just some consistent, slight, harsh behavior on its own outputs, but nothing like what we were seeing with Google. Once again, we also did bootstrap these values to estimate confidence intervals, which confirmed that Google's inflation was statistically robust and OpenAI's effect of being quite neutral was also robust in this case. And our key takeaway here was that Google was the only one that was demonstrating strong self-evaluation bias in our experiment ecosystem here. And once again, we did run multiple trials, and this wasn't just a one-off outlier. In this case, this was quite consistent across the board when we ran this. And we can jump to the next slide now. And as a little bonus here, beyond the world of self-evaluation bias, we also did some digging into what model consistency looked like. Model consistency in this sense referred to how stable an agent's scores were across repeated trials with different evaluators. So I did mention earlier that we ran multiple trials for all of this. How and what this graph is kind of trying to tell us is when we ran those multiple trials, how how inconsistent were our evaluation scores? Like were we getting a score of like 30% at one point and then were we jumping all over the place? Or did we tightly cluster in some areas? I think we lost the screen share for a moment. Oh, I think you're on mute, Elizabeth. Okay, I think we're going to come back up in a moment. Okay, great. We're back. So just to recap really quick, we just wanted to understand how much deviation there was when we were doing these evaluations. Were we getting some random scores across the board and then just taking averages and running with those? Or were these evaluations just consistent in themselves? And we did this for, again, every single one of the agents. And for each evaluator, we were able to see just how tightly these evaluation scores were clustered. And then this axis here is our deviation from the human score in this case. And we were able to understand, one, what this clustering meant, and two, was an agent in general, no matter what the evaluator was, were their scores close to our human baseline in this case. So this was in the OpenAI case. We could see that in the case where the OpenAI agent was assessed by Anthropic, there's a consistent jump above the human baseline versus for the other three evaluators, it's relatively close, with Quen being probably the most consistent way to judge this OpenAI agent. If we jump to the next slide, we can see how this actually played across the board. This might be a little
Quick
hard to.
question,
Oh, yeah.
Sanjana.
Mhm.
Would you say, based on these results, that the Anthropic models as an evaluator was just like optimistic in general? It seems like it was often assigning scores that were higher than the human eval scores, like
Yeah.
across the board.
Was that in relation to the past slides and experiment there?
Kind of, yeah. Seems like the Anthropic model was giving kind of high scores across the
Yeah,
board. It's like the
that
Anthropic
is.
model is really generous with.
Yeah, I would say that that probably is like something that I did notice in this case, and again, I was saying that we ran these like multiple times, so these were quite consistent. And I think that's another pattern to take away from this, saying like, okay, if I'm possibly like running with these agents, maybe Anthropic isn't the strongest way to go about this, and you could like take a look at this grid and say maybe like based on a specific model. You can find like the most consistent evaluator in this case. But yeah, I also did pick up on that pattern for Anthropic.
Yeah, so it's not necessarily biased towards itself, but it just has a positive bias overall.
Yeah,
Kind of interesting.
that was a good observation there. Um, but yeah, just to wrap up this last slide on like model consistency, which was our little bonus one here. Um, we did see that funny enough, Anthropic's like the top right corner here. It did seem to say quite consistent. Like along the human scores, but again, as we were saying that we did see those those positive biases in some case. But if you look at Google in the bottom left-hand corner, kind of seems like all over the place if you look at all of its evaluators in context. Um, this graph might look a little small, but if you are more interested in understanding like model consistency in this context, I'd recommend going to the right up there and like digging a little deeper into this experiment that we also had over here. And if we can jump over to our last slide. I just want to note some couple limitations with this experiment. When we ran each agent, we had a data set of about 50 queries, and then we applied bootstrapping to estimate those confidence intervals I was talking about and reduce sensitivity to this limited sample. I do want to say that because this data set was intentionally small, this wasn't a formalized research experiment, and we don't want to say Google in every single case is going to evaluate its outputs um, so biased compared to anyone else, but it was more of a directional pattern that we came to and we found quite interesting. The evaluation in this context was emphasizing orchestration quality, which meant that other dimensions, maybe such as creativity or style, weren't captured, and be interested to see how maybe evaluation in different dimensions um, maybe or may not lead to similar results in this case. And we also grounded everything on human labels. Um, in the evals world, human labels are often our strongest source of ground truth and understanding what our baseline is, but humans themselves are also quite biased. So in any case, that is something to be thinking about. Yeah, but that kind of wraps up the presentation aspect of this. And if you have more questions on this, happy to talk about it. Or also encourage that you check out the full write-up on this. It's on our blog, and it goes into much greater detail.
Thanks, Sanjana. I had one more question actually,
Mhm.
because so this experiment that you ran is a little bit different than the pairwise comparison ones that I was reviewing the literature on, in that you weren't asking for a preference between two outputs, right? You were asking for like raw scores.
Right.
So, and you still observed the bias. So that's really interesting. I feel like sometimes when I see those pairwise comparison tasks, I'm like, well, we're not doing those types of evals. So if there's a bias, like it doesn't really matter, because I just want the model to assign a raw score. And if I'm only showing it, outputs from OpenAI and I'm using an OpenAI judge, like what does it matter? But it's really interesting that you observed that the models inflate their scores. It's not just that they prefer their outputs over others, it's that they actually assign higher scores in the absence of other alternatives. Um, so
Yeah.
that's really interesting. I feel like more kind of relevant to the types of evals that most people are doing.
Mhm. Yeah, I would absolutely agree. I think the pairwise experiment definitely got me thinking about a lot of like how to evaluate this and like what does that look like in context. And in this case, as you were saying, it was like a raw score in an isolated environment. And we did our like trace level evals in this case, like putting the entire agent's output essentially into the evaluator. And yeah, it was cool it was interesting to see how like it was quick to pick up on their own patterns and their own outputs and say, yes, I'm correct.
Yeah, 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 totally. Pretty freaky, and it would be hard to detect if the model was doing that in the absence of a controlled experiment like this. So it's definitely something to watch out for.
Absolutely.
Cool. Thank you so much, Nansuna. That was awesome. And as a reminder to everybody, we have the recordings of all of the prior sessions on YouTube. You can check out at this QR code. Also, you should sign up for the next one. We are kind of taking it back to basics for the next session. This date is wrong, but it's in 2 weeks from now. And we're going to be talking about sort of the basics of LM as a judge, how to write a good prompt, how to sort of get started if you aren't familiar with the research. It'll be more practical focused. And also, I'm hosting office hours every week. Anybody can sign up for these, and we can just talk about whatever you want, evals related, whether that's best practices, help with your particular use case, or just tips on getting the most out of Arise or Phoenix.